Class today. I got all like I don't understand how I got confused on this. I thought this was the class I was supposed to play the video in, so I was getting ready for that. But that was third hour, so not the one on 1.5 speed to get tucked in. We're gonna do a little labbage today. It looks like I've got 16 more value affirmations out there than I need. I think I'm about 77 right now total. We're gonna hit up a little lab here in a second. AP Physics need to knows. This link here, and then I have it'll permalink down here in the other links section. And that's just a module where I'm kind of curating resources, helpful explainers. Like today we're going to use Desmos. Like how many of you have extensive use of Desmos? Oh, you guys. Fair enough. We'll see how that goes. Because man, last period 3 there was like, so I got a video that kind of walks through some stuff. Some stuff you don't know, like how I grade labs, so I have some things in here that I'll reference later. There's a YouTube channel for this class where it's got a bunch of old videos and stuff. We probably have already hit on how to do class notebook business. So, anyways, AP Physics need to knows. And the YouTube channel. So, like last year, Zoom class was just recorded. I just shared the link in a spreadsheet after class. What I'm trying to do this year is I'm screencasting right now. Okay, so that's what's going on here. So you are being recorded. Watch your language today, please. And I don't know how well it's going to pick me up if I'm walking way over here. I may need to move my rig back over here up front so it picks me up. But anyways, what I'll try to do then is link those, store those somewhere, and it'll probably be on that AP Physics YouTube channel or something. You can just go catch class. So when you're gone for whatever, you can take one out. All right. So pre-test, took the pre-test yesterday. I think everybody was here. I've got a couple yet to take it from period 6 and period 3. How'd it go? I don't understand this. Like, it's pertinent that we're talking about graphs today, because like you look at that at first, you're like, hey, we did all right, yeah. Except that here's 0, and there's 100%. So I forgot to do one of my favorite things. Shush. I forgot to do one of my favorite things, which is have you like predict your score. And I don't know what it really says, because like the incorrect responses are designed to appear correct to you if you hold those understanding of physics. So it's possible to feel like things went okay and then have it not go okay. I did remember to ask them to do that 6 hour, and there were actually 4 out of 23 people that were spot on with what their scores were. Somebody thought they got a 12, they got a 12. Somebody thought they got a 3, they got a 3. Okay. But there were also a couple of people that thought they got a 26, they got a 5. And I don't think it speaks to like an arrogance or anything per se, because it probably felt like they knew what was going on looking at the answers. But they don't. So then I gotta fight to see, like, do I wanna let you know your score and then have you like think like, oh gosh, it's all over for me, I got a 1 out of 30. Or do I just point at that graph over there and show you based on past experience, this is set up the right way where 0's on the left, by the way. So 0 out of 30, 30 out of 30 post test. That's what happens, okay? I need you to know from the pre-test experience that the average in here was 8 out of 30. Nice. That's above 25%. That's what I want it to be, though. Like I had to take a required psychology class my freshman year of college. I got 100% of the pre-test. Dang. I slept through class pretty much the whole year. Took the final. Guess what? The final was the pre-test. Got 100% of it. Like, what was the point of that? Okay, at a private college, what something like that costs, that's worthless. So that we have most people kind of hanging out over here is a good thing. You're going to get your money's worth. Okay. Nobody had a 30 out of 30. This class is free.
You're not paying for everything this? Costs something.
You're not paying for this,
but it still costs something.
Damn. All right. So
That's your energy.
thanks for staying focused. We got got here at 23 out of 30, but chances are there are quite a few people that think they're at 23 out of 30 that are actually a 5 out of 30. So I'm just cautioning you. Shush, please, let the man talk. That you have to be aware of the fact that there are a lot of people in here that have a fair bit of growth in learning fields that you shouldn't necessarily trust your intuition, your physics intuition, as you're walking in the doors here, because in general, there's a lot that we don't know. There's a lot that we know that is probably not correct. So be careful, be curious, and we'll have a good outcome. Okay. So that's kind of that thing. Let's scrolly here. So here's where we're going today. Okay, we're going to do our first sort of lab activity, and that typically starts at the beginning of the unit with the question of what do you notice? Okay, so but what I usually write is what do you notice? Okay, yeah, what do you notice? Talk to your neighbor real quick. What do you notice?
Gibberish.
Same eight has the same
It's like all the same. No, it's not Laura.
All right, hey, take one down, pass it around. Take one down, pass it around.
Esse quadrado é torcido financial república quisiera este libro como existe entendimiento espera más
We're missing
Oh,
line on the
this
bottom.
was lazy last time. I just left it. So you get a fresh copy for yourself. Oh, hey, perfect.
They're already eating.
One more.
I have never read.
Hey! What do you notice? Hand in the air if you're a true player. Ian!
Spanish.
Spanish. What languages are you taking here at West Side?
Spanish.
Friend, you're taking Spanish? She's not taking Spanish. Somebody that's taking something else, what did you think when you saw this? Okay, different language for sure. If you notice that it's in Spanish and you're in Spanish, what do you notice about the paragraphs?
They're all the same.
Okay, but if you weren't in Spanish, a lot of people are just like, oh, they all start with D. Okay, they see that part, right? But he's in Spanish, so he noticed, oh, you know what? Desacopado lector. Well, you probably read it better than I would. But anyway, yeah, it's the same paragraph. But what do you notice? Yo. Alright, with the mass, we got to use the outdoor voices in here, but thankfully he talks with his hands. So you were saying like the skinny ones are long.
Yes, it goes like it gets longer, the skinnier.
Okay.
And then
The wide ones are.
it goes longer and
Yeah. Okay. So cool. Right? That's what we noticed. I should be writing this down. Let's get that. So Spanish, same words, wide and short, or long and skinny. Okay. That's kind of it. Oh, I don't want to give that away. So once we've had a moment to kind of survey the scene, check it out. This will be true in physics labs. We want to know more about it, best way to do that, at least in here, as we're concerned, is to make some measurements. So what are some things, if there's some kind of relationship here, what are some things that we could measure directly? Run that by your neighbor real quick. What are we going to measure here?
The letter counts are identical.
Yeah, you can measure that.
Why?
All right.
Because
What are we going to measure directly?
Width.
We can measure the width directly. What kind of utensil?
Ruler.
Ruler. I got those. Rulers are right up here if you don't have one. What else are we going to measure directly?
The height.
Height. Okay. Measure directly. So we're going to use the ruler for that. So I heard some mention up here as well of a word count or a character count. I mean, what do we kind of already know about that?
they're all the same.
It should all be the same. Okay. So if somebody's acting up, we'll make them count on the letters, but otherwise we're just kind of know that's a thing. So what can we measure directly? We're going to measure width. We're going to measure length. What can we measure directly? Come on, screens. So that's what I'll usually write is what can we measure directly? We said width with a ruler. We said length with a ruler. And you said character / word count with our eyes. I don't know. Okay. Mr. Honeywanger, write on this. So the experimental design question, should you encounter one of those, is going to provide you with a list of equipment, and you have to list out what equipment you're using, what you're going to measure with that equipment. Okay, or the process. So just modeling it throughout the year. We're going to measure length. We're going to measure width. Maybe a character count. All right. So the last piece of this puzzle then is the scientific question. Okay, and the format for that will be revealed if the screen flickers back on. Is it back yet? There we go. All right. So, what relationship, if any, exists between, why am I putting the question mark there? It doesn't go there. We're not done asking the question yet. The question is length and width. Okay, what relationship, if any? What is the purpose of including if any in this?
Because if there's no relationship, you don't have to.
That could be a thing. Don't we just like draw our own conclusions and force the information to fit our preconceived notion of what should happen?
That's not bias.
Oh, not science. Okay, so that's where the if any comes in. So wait for that. That's Chekhov's if any. Okay. At some point later in the year, there may be a situation where there isn't any. So that's a possibility. Okay. So be cautious about confirmation bias. All right. That's about the size of it. So then the other thing that we need to do is kind of pre-plan our graph. What will that look like? Scroll, bruh. There we go. So length and width. All right, Feng Shuo, what do you want to put on the vertical axis? Length. Okay, and then make sure you include your units of measure there. And then that leaves for the horizontal axis width, units. Sometimes the choice is not arbitrary, but in this case it kind of is. So there we go. You already probably have some idea how this relationship works. But you're going to graph this in Desmos.com. What do we say here? See, this is dumb because to go to the calculator, I actually go to scientific. But then if I want to graph, you would think go to graph. No, you go to calculator. Yep, there we go. That's what we want. Desmos.com/calculator. If you are not very familiar with Desmos, again, that is back on the module here. You can go to the Desmos. I got a little video action there for you. Okay. Work with your buddy. If you don't have a buddy, you go find a buddy. You have any singletons out there? Okay, or if you want to do a group of 3 or whatever, or make it work. Whatever happens. Or yeah, YouTube buddy, and then we got buddies, buddies. So just divide and conquer. I'll measure these paragraphs. You measure these paragraphs. Get the data in Desmos. This is that thing about checking the marshmallows. We graph as we collect data, not when we collected all the data. Graph now, so if something screwed up, you're gonna notice it. Like, oh man, I forgot to carry the 2s. Oh. Ooh, what else does P5 need? Watch the video. Oh shoot! What's up?
Length is height. Length was the y-axis. Mr. Rodin, was the length of y-axis?
Sure, it's not just.
Uh-oh. Oh.
I was like driving. was Friday. Last day. Salad and our closest. It is. But that is not an exponential graph.
Ooh. That's an important comment to make.
Just say.
Oh, we didn't talk about any of that, did we? Oh, crap. Okay. All right. Hey, how many people have ever read XKCD before? Webcomic.
Yeah.
XKCD. I got one. All right. Cool. So what's super cool is the person that does XKCD has a couple of books, one of which is called Thing Explainer, and a copy of Thing Explainer came with the textbook for this class, and I think they weave them into the text a little bit. What Thing Explainer attempts to get the point across about is the importance of using simple language. Okay? And not to pick on anybody, but I've heard this word over here, and I'll just warn you, like, that immediately earns the Inigo Montoya meme when I'm giving like feedback in Canvas or something like that. Okay? Which is the whole like keep using that word, I don't think it means what you think it means. The word was exponential. Okay? That's a fancy word with a very specific meaning. We can still say something that's true, but maybe back that down a few pegs. And that's kind of what this gets at. Like if you really understand something well, you can explain it in simple terms. So this whole book is all these diagrams of different things. Like for example, here it's the U.S. Space Team's Updoor 5, which is the only flying space car that's taken anyone to another world. And it's explained using only the 1,000 words people use the most often. 1,000. What's that all about? Why didn't it just say 1,000? Yo?
100 is one of the 1,000 top words, but 1,000 presumably isn't.
1,000 is not. Yeah. So we're talking using simple words, okay? So when we do that, we say things like this part right here. You can't really see the whole thing. I gotta scroll a little bit. But this is the thing to help people escape really fast if there's a problem and everything is on fire, so they decide not to go to space. This is the thing to control which direction the escaping people go. This is the stuff to burn to make the box with the people in it escape really fast. Okay? And then if we keep scrolling, we see the place where the fire comes out to help them escape. You see the people box, the door, the chairs, the part that flies around in the other world and comes back home with the people in it, and then it falls into water. The cold air for burning and breathing. Okay? That part had a very big problem once. Okay? And then like down here, you can see we've got storage for more breathing type air for burning, cold and wet. And then there's more of the funny voice air for filling up space. What is funny voice air?
Helium.
Helium. Okay. So it's comical, but it's getting at a very important idea that we don't want to hide behind overly complex language. Okay. So the more simply you can state what you've got in front of you, the better. Okay. And we'll add in complexity and specificity as we go, but as I pointed out earlier in the period, the level of understanding that we're at right now, we don't know a lot, so I would say proceed with caution, okay? So don't call it exponential unless you know for sure that it is. What's a safer word to use there? I'd say curve, okay? So call it a curve if it's a curve right now, okay? Be cautious.
I already know what it is now. Yeah. Yeah, I know what you mean.
What up?
So how do we go by the number, like section 1, 2, 3, 4, 5, 6, 7, 8?
What's up?
Like how do we label the section 1, 2, 3, 4?
However you want to do it, but then just make sure you get all that data into the data
And how
table.
so wouldn't the graph look different for everyone?
Well, let's find out. Right? Okay, so again in Desmos, like pro tip, it just looks like this when you come in. You come over here, you can sign in with your school Google. It's always good to give it a title, but I don't have anything yet, so we'll let me title. This is an important button, the add item button. I can add a table, and that's where I'm going to put in numbers. Okay, hopefully numbers that like make sense for what we're doing. And then put some more numbers over here. All right. Now, I don't see a graph yet. Important new button in Desmos. I mean, it's like 2 years old. Magnifying glass, zoom fit button. Boom. There they are. But I will caution you this. One of the things that we're typically interested in here is how this all relates to the origin, how it relates to 0, 0. So kind of scale your graph from 0 by default, right? Again, if you're not sure how to do things like label it or put in an expression or anything like that, check out that video that's on the Canvas. That'll talk about a little bit of that stuff. Okay. If you got questions, by all means, I'm in the room. So just hit me up in the chat. Whoa, what'd you do? How'd you do that? I don't even know how to do that. No, but the dark background. Look at that. You just taught me something. Sweet.
I prefer what if over singular.
Yeah, same. What if it's crazy? All right. So you have all this because you just put them in individually, but you put them in a table. But it works. Okay.
Yeah, can I put it like this?
Put it like this. I don't prefer that way. Because we're gonna do something that is a lot easier if you have them in a table. We're gonna do a process called linearization. Chaos. And you are gonna individually need to submit the graph. Collaborate on data collection. So, oh man, I don't want all that. All right, again, if you're not totally familiar with Desmos, I've got axes labels. I called it height and width, but in here we're calling it length and width, so I'm going to not hit that button. I'm going to hit the Llave Inglesa, the wrench here. And x-axis, that's cool, but I'm going to change the y-axis label. I'm going to call that length. Boom, now it shows up on there. I also like, why do I keep hitting the globe? I also like, do they not have projector mode anymore? There we go. This used to be called projector mode. It just makes it bigger, helps my old eyes see it. Okay. If you don't know how to do things like add the labels, that's where you go to the AP Physics Need to Knows. And what the heck, buddy? Hit save. And I walked through that in the Desmos video. So here's how to Desmos, and that's in there. We're going to need to do some things like add in an expression and then add in some notes, and that's all in the Desmos. So again, hit that up. 28, 22. Goodness, man.
Hey, Mr. Hart, do we have to,
What's up?
do we have to like share this here or something?
You're gonna eventually, but not yet. You're still doing silly things. All right. So, generally speaking, it looks like we're here-ish. So here's some things to note. This is period 5, right?
Yes.
So I accidentally skipped the video, or it just took so long with the spaghetti tower the other day. I skipped the video that kind of talked about what the metaphor of the whole marshmallow tower thing is. And it's this idea that if you just build this tower out of spaghetti, to build a tower out of spaghetti, and you're not thinking about the marshmallow, then like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, when you go to put the marshmallow on top, the whole damn thing collapses. Okay? Whereas, if as you are building it, you're putting the marshmallow on periodically to make sure that it's still supported, and then you build a little bigger, put the marshmallow on again, okay, still works, build a little bigger, take the marshmallow back on. If you're constantly checking to make sure that the marshmallow is supported, which is the purpose, right, then you have a much greater chance for success. If you're not doing things in a purposeful fashion, you're just going to end up with your marshmallow on the table. Okay, not to make fun of those groups again, but it works. So in here, the marshmallow is the mathematical representation that we're trying to get out of this thing, the relationship. Okay? Graphing it like we're doing, you know, if as you were measuring, you were putting it in right away, that to me would be checking the marshmallow. Because if all of a sudden I get a data point that maybe was like up here, ooh, that's not going to support the marshmallow. I'm going to go back and double check that data point. Oh, you know what? I mismeasured. I wrote something correctly. It should be here. Okay? This looks like it's going to support a marshmallow. To check, we're going to insert an expression. So you go to that magic plus button. And hit up expression. You could just type it in. You don't have to do this, but I'm doing it. Y equals. What are some of your favorite mathematical expressions?
MX plus B.
MX plus B. All right, and here it's AX plus B. And I skipped by that too quickly. Let me back up a step. All right, so if I type in Y equals AX plus B, it gives me an angry triangle, and it says too many variables. Try defining A or B. Would you like to add a slider? Yes, I would. And now it lets me change the value of A, and I can see that that affects the slope. And I can change the value of B, and I can see that affects the vertical intercept. So maybe I decide to go, well, and it doesn't go high enough. So I could change this to 20. Now I can slider it all the way up to 20, and maybe this needs to be negative. Okay? So there we go. I got it, right? Well, the TV didn't like it. So this is an important graph skill. If you're graphing data, and when you put your OK fit line on there, your data at the beginning and the end are on one side of that line, and your data in the middle are on the other side. Okay, see what I'm talking about? Like here, it's below the line, and then the middle, it's love line? It's not a line, friend. That's probably some kind of a curve of sorts. So y equals x, chill bro. Y equals x plus b is not the correct fit to represent this data. Okay? We talked about this in the very beginning when you were just noticing things. You said you got the skinny, tall paragraphs and you got the short, wide paragraphs. So what is that? We'll just do the quick survey. Who all knows what that's called mathematically when the one thing gets bigger, the other thing gets smaller? 3 of you? 4 of you? Oh, yeah. Okay. You had your hand up highest and earliest. Yes?
I know the equation.
What is the generic form of the equation for this?
1 over x.
In other words, it is a relationship. What kind?
Inverse.
It's an inverse relationship, right? When you think inverse relationship, you think y equals 1 over x. So let's type that in. Let's see what happens.
Y.
1 over x, right? Because that's what inverse relationships are. No, that is one inverse relationship, okay? Where y is equal to 1 over x. So I don't want to put 1 there. What do I want to put there? Don't tell me a number. What do I want to put there?
45 is
No, don't tell me a number is what I said.
Variable.
A variable. So I'm going to make this be my a. Boop. And I keep hitting that stuff. Give me the slider, bruh. Oh, I have a slider for a. Boy, negative 1.2 is not correct. Better, better, better. Oh, it doesn't work. Well, I can make 10 a bigger number by clicking on it. And then hopefully I can find it. Okay, hey, one other thing, right? Because it's doing this down in the third quadrant. I don't have data in the third quadrant. I don't want that. So add in a little set thing here that tells it to only plot values where x is greater than 0. Okay? Right? Woo, there we go. Pretty. So find the correct value for a. I don't want to know it right now. I know it, but I don't want to know it. Okay? So see what you get. What do you call it? Length. All right, where are we at? 160, 122. This is gonna be a fun game every day. The class is ended at different times every day. So if you just start typing, it freaks out. You have to go use that magic plus button and add a note where you're gonna discuss the equation. Now, y equals a over x is not descriptive. We want our equations to be descriptive in here. It's not y equals a over x. What is y in this thing? Verbal? So length. X is width. Okay, so I've got length equals something over width. We get some number. Did you get a number? 46. 47. Anybody get like 13? What'd you get? Okay, nobody used inches. Come on.
I used inches.
What'd you get for your number?
I got 6.6 and I subtracted 0.2.
Okay. So this number might be 7-ish, might be
I got 7.
7. Okay, that's what it was. All right, yes. Could be 7 or it might be 46. Or it could be 42. All right. Now, we're not done yet. Because we need to think about the units that go on this. How many people think they know the unit for 42 or 7 right now? I already know the unit. Okay, not a ton of people. So we need to do a little dimensional analysis. The Left side of the equation, if I measured everything in centimeters, this is centimeters over 1. This is an equal sign. It says equivalent, both sides. Right now, I have unknown above width, which would be in centimeters. They're not equal right now. What are we going to put there to make them equal? So I could guess centimeters. Seems like a lot of things in centimeters. Is that going to work? Now, it says centimeters over 1 equals 1. That's going to cancel out. So run it by your neighbor really quick. What do I got to change over here so I get centimeters equals centimeters? Both sides. Neighbor, neighbor, neighbor.
Sorry.
You alright? What's up?
I have an individual.
Okay, I'll hit you up in a second. Alright. So you said it's going to cancel out. What do I got to add up here then? I'm going to add a question mark. So if I just have this, it's going to cancel out. What do I still need upstairs?
Centimeters.
I need another centimeters. So centimeters times centimeters. In other words, I've got to have centimeters squared over centimeters on this side. So 42 centimeters squared. What is centimeters squared
Area.
smell like? Smells like area, right? Like feet squared, inches squared, square miles. It's an area. 42 centimeters squared is the constant in our equation. We need to add a note where we discuss the significance of the constant. Because here's the thing about it. When we're collecting data in here, things that are held constant tend to show up in the equation as constants. 42 centimeters squared. Take a stab in the dark with your neighbor. What do you think the significance of 42 centimeters squared as a constant is? Or 70 squared?
What you need? My constant is 45.
So the constant, you got 45, that's fine. I got 39. So you get 39 centimeters squared, 46 centimeters squared. Smells like area. What about this has anything to do with area that would seem to be constant? These paragraphs are?
42 square centimeters.
Why are you confident in that? What do we know about these paragraphs?
They're all
They're all the same, right? One of you crazies count the letters? We don't need to, right? You just read it. So, yeah, these all have the same area. I mean, look at the equation we came up with. We just did all that work to come up with width times length equals area. Oh, but what I'm trying to point out is that the constants that we get from these graphs, they have some kind of meaning. We have to be able to figure out what that meaning is. So that's what you're explaining in your note about the constant. You'll need a note with the equation in the proper format, a note with the discussion of the significance of the constant. Okay, what else do we need? Pretty good. Questions, concerns? You can keep that if you want, or you can recycle it. There's recycling over here. I got a little ton on the floor. Okay. Ian, you have an individual question?
Oh,
Alright. Increase the piece.
Do we give this back to you?
Or you can recycle it or whatever. I don't need it.
no, he's willing to pump his eye. No, I see.
Means, you know, what am I supposed to do during prep periods? Like playing horses? No, I get swole.
Yeah, obvious.
Yeah. Can't get to educational games without the weight room.
Gains, gains.
Oh. Oh, yikes. Hi.
This is my first day.
Ruba, nice to meet you. I'm Mr. Harding. Sit wherever, find some friendly faces or something like that, and we'll kind of get you caught up. There are, I'm sorry I didn't reply to your email, but there's a variety of like assignments in Canvas that you'll see. Just catch up on that over the next week or so. We'll be good. Dang, buddy. What's going on here? Who? Oh. Wonder.
I can assure you it does not.
What up?
Should I just pick any seat because it's a switch periods?
Damn it, Quarantine. Which period are you coming from?
I mean,
Period 3?
yeah,
Okay,
I wasn't kidding.
that'll work. Yeah, just sit wherever. Gosh darn it. That's not what I wanted. That's what.
Why are you lying?
Oh man, gosh darn it.